The James Webb Space Telescope, JWST, has once again amazed the world with its cutting-edge discoveries, this time by capturing the most detailed infrared transmission spectrum of an exoplanet to date. This unexpected discovery has shocked the space industry, as it brings to light new information about exoplanets that researchers simply hadn't expected. The most recent analysis of an exoplanet outside our solar system demonstrates that the JWST is indeed ushering in a new era of space exploration. One of its most significant finds centers around the exoplanet WASP-96b, a mysterious gas giant that researchers have been studying in depth. WASP-96b is a gas giant that orbits its host star WASP-96 in the constellation of Phoenix. It is located approximately 1,150 light-years away from Earth and was first discovered in 2014. Despite its discovery a decade ago, this exoplanet continues to puzzle scientists due to its unique characteristics. The planet is about half the size of Jupiter, but has an atmosphere that is significantly different from any gas giant in our own solar system. It orbits its host star at a breathtakingly close distance, completing a full orbit in just 3.5 Earth days. This proximity makes its atmosphere incredibly hot, reaching temperatures as high as 725 degrees Celsius, effectively turning it into an inferno. WASP-96b's unusual features made it an ideal candidate for in-depth study by the JWST. In June 2022, the Space Telescope delivered the cleanest and most detailed infrared transmission spectrum ever captured of an exoplanet, providing groundbreaking insights into the planet's atmosphere. JWST's observations of WASP-96b have yielded some truly unexpected results. For the first time, scientists were able to use Webb's near-infrared imager and slitless spectrograph, NIRIS, to study the atmosphere of a distant planet with an unprecedented level of precision. The analysis revealed the presence of water vapor in the atmosphere of WASP-96b, along with evidence of clouds and haze. These findings were particularly surprising because, based on prior models, WASP-96b was expected to have a relatively clear atmosphere. Instead, the discovery of cloud formations in this scorching hot environment has left astronomers reevaluating their understanding of such gas giants. The transmission spectrum is produced when starlight filters through a planet's atmosphere and is compared with unfiltered starlight. This method, known as a transit or transmission observation, allows scientists to study the composition of a planet's atmosphere by analyzing how different wavelengths of light are absorbed by the gases in the atmosphere. In the case of WASP-96b, Webb's instruments created a detailed diagram from 141 individual data points, each representing a specific wavelength of light. These data points revealed intricate details about the exoplanet's atmosphere, including the presence of water vapor. The ability to detect such details in the atmosphere of a distant planet has profound implications for future exoplanet research. Previously, such precise measurements were impossible, even with the Hubble Space Telescope. But with Webb's advanced infrared capabilities, scientists can now detect important gases such as water, carbon dioxide, and methane, as well as key biomarkers that could indicate the potential for life on other planets. One of the most exciting aspects of the WASP-96b discovery is the technology that made it possible. The JWST's NIRIS instrument is particularly well suited for studying exoplanet atmospheres. It uses a method called single-object slitless spectroscopy, SAS, to capture a broad range of wavelengths in a single exposure, allowing scientists to study the entire light spectrum of a planet's atmosphere in great detail. This technology simplifies the analysis process and improves the quality of the data collected. By analyzing the absorption patterns in the light spectrum, scientists can identify the presence of specific gases in the planet's atmosphere. Each gas absorbs light at different wavelengths, creating unique patterns that act as fingerprints for the various molecules. For instance, The water vapor detected in WASP-96b's atmosphere was identified by its distinct light absorption pattern. The data collected from the transmission spectrum also provides information about the temperature of the planet's atmosphere. The higher peaks in the spectrum, which indicate strong absorption of light, reveal that WASP-96b's atmosphere is extremely hot. The ability to determine both the composition and temperature of a distant planet's atmosphere in such detail is a remarkable achievement in the field of exoplanet research. The discovery of water vapor in the atmosphere of WASP-96b has sparked considerable excitement among astronomers. While WASP-96b itself is not considered a likely candidate for life due to its extreme heat and gas giant status, the detection of water vapor is an important milestone. Water is a key component for life as we know it, and finding it on a distant planet indicates that there may be many more worlds out there that have the potential to harbor life. Additionally, the discovery of clouds in the atmosphere of WASP-96b was unexpected. Most gas giants that orbit their stars as closely as WASP-96b are believed to have clear atmospheres because of their high temperatures. However, the presence of clouds suggests that there may be more complexity to the atmospheres of hot gas giants than previously thought. This finding could lead to new models of exoplanet atmospheres and change our understanding of how these distant worlds evolve. The level of detail in the data collected by the JWST is nothing short of extraordinary. The transmission spectrum consists of a series of light curves that show how the brightness of the star changes as the planet passes in front of it. By analyzing these light curves, scientists can infer various properties of the planet, such as its atmospheric composition, temperature, and cloud cover. For example, the presence of water vapor was determined by studying the peaks in the light curves, which correspond to specific wavelengths of light that are absorbed by water molecules. The gradual decrease in the spectrum also suggests that the planet's atmosphere is cloudy. The data even allows scientists to make predictions about the density and height of the cloud cover, offering a more complete picture of this distant world. What's more, the JWST is capable of detecting biomarkers, molecules that could indicate the presence of life. Although WASP-96b is not a candidate for life, this technology could be used to study Earth-like planets in the future, providing the first real opportunity to detect signs of extraterrestrial life. The discovery of water vapor and clouds on WASP-96b is just the beginning. The James Webb Space Telescope is expected to revolutionize our understanding of exoplanets over the next decade. While WASP-96b is a gas giant and not likely to harbor life, Webb's instruments are capable of detecting Earth-like planets with far more potential for life. The JWST has already proven itself to be far more powerful than its predecessors, including the Hubble Space Telescope and the Kepler Space Telescope. Whereas Hubble provided valuable data about distant worlds, it was not designed specifically for exoplanet research. Kepler, launched in 2009, was groundbreaking in its ability to detect exoplanets by measuring the tiny changes in brightness that occur when a planet passes in front of its star. However, neither Hubble nor Kepler can match the level of detail provided by Webb's infrared spectrographs. With its ability to detect the signatures of water, carbon dioxide, and other gases, Webb is expected to vastly expand our knowledge of exoplanets. Researchers are now on the threshold of discovering new worlds that may be capable of supporting life. The telescope's unique capabilities also allow it to identify light emissions that could indicate technological activity on other planets, such as city lights or industrial facilities, potential signs of advanced civilizations. While the data from WASP-96b is still being analyzed, scientists are already looking ahead to what comes next. The JWST is set to study many more exoplanets in the coming years, and its advanced instruments will allow for even more precise observations. Researchers expect that Webb's discoveries will continue to push the boundaries of what we know about distant worlds. The ultimate goal of exoplanet research is to answer the age-old question, are we alone in the universe? By studying planets like WASP-96b, scientists hope to gain a better understanding of how planetary systems form and evolve. This knowledge will help researchers identify the conditions necessary for life and improve our chances of finding habitable worlds beyond our solar system. With the JWST leading the charge, exoplanet research is entering a new and exciting phase. The discovery of water vapor and clouds on WASP-96b is a major milestone, but it is just the tip of the iceberg. The space industry is on the brink of many more groundbreaking discoveries, and the James Webb Space Telescope will continue to be at the forefront of this incredible journey into the unknown. As we push deeper into the cosmos, the possibility of finding life on other planets grows ever closer. While WASP-96b may not be home to life, the data gathered from its atmosphere provides a valuable stepping stone toward understanding the many mysteries of the universe. The future of space exploration has never looked brighter, and the James Webb Space Telescope is lighting the way. In summary, the James Webb Space Telescope has revolutionized exoplanet research by capturing the most detailed infrared transmission spectrum of WASP-96b, revealing water vapor, clouds, and haze in its atmosphere. While this hot gas giant may not support life, Webb's advanced technology opens the door to future discoveries, bringing us closer to finding habitable planets and potentially even signs of extraterrestrial life. The future of space exploration has never been more exciting,